Hi everyone, this is a tutorial on how to complete numbers 2 and 3 for project number 4 for Size 608. So number 2 asks you to do a one sample t-test and calculate, so one sample t-test for FEM against a model saying that the true mean of FEM is 4 and against the model that says the mean is truly 4.1, and then to figure out which of those two models provides the best fit. So I'm going to show you how to do that. I'm going to change my test value. So I'm going to compare our FEM data to different models rather than 4 and 4.1 so that you guys can see how to do it but not see the exact answers, because I want to make sure you know how to do it. But let's go ahead, I'll show you how to do it. So I'm going to compare the FEM data to a model saying that the true mean is 4.1 and then a second model that the true mean is 4.2. So sorry. All right, so you're going to go to Analyze, Compare Means, One Sample t-test. So we're going to compare the mean of FEM, which I think in this data set is like, in yours it's going to be 4.0881 or something like that. I don't think I changed the FEM data. I think I'm only changing my test value here. So you guys will enter 4.0 here, but I'm going to do 4.1 as my first one. So I'm testing FEM against 4.1, and I'm going to hit OK. All right, so it shows you here the mean of FEM is 4.08. And then if you look down here, here's the result of our one sample t-test, and it shows you the test value of 4.1. And what you guys want to look at is the probability of this model, the 4.1 model, given our obtained FEM mean of 4.08. So how likely is it that the true mean of FEM, whatever that is 4.1 given our obtained mean of 4.08. And you want to look at this probability value, 0.743. That's pretty high. There's a 74% chance is the way that you would interpret that. So that's pretty high. Now I'm going to compare it to a second model. So I'm going to compare to a model testing 4.2 as the true mean of FEM. And then we're going to compare our probability. So again, you could just go to Analyze, Compare Means, One Sample t, and then just change your test value to whatever your second value is going to be. For the project, it's going to be the one that I just did, 4.1. I'm changing mine to 4.2. Click OK. And again, it shows you the mean of FEM up here, but what we want to look at is the probability of this model, 4.2 model, given our obtained mean of 4.08. So how likely, if the true mean of FEM were 4.2, would we be to get a mean of 4.08? And it's pretty unlikely because our significance value is 0.002. So there's a low probability of this model being the true mean given our obtained mean of 4.08. So what you want to do for the project is compare your p-values. Look at which value is most likely or most probable, and whichever one's most probable is the one that fits better. So, you know, in my case, I would compare 0.743 to 0.002. This probability is much higher. So I would say that for me, 4.1 model is a better fit. Again, your results are going to be a little bit different because you're testing different models. But that is how you would do it. And yeah, I think that's all I need to show you for that. Next, we're going to move on to number 3, which asks you to do an independent samples t-test or two sample t-tests. Those both refer to the same thing. Let me just check on the time of the video. We have a few more minutes left on this. I can keep going. All right, so the way that you do an independent samples t-test is you go to Analyze, Compare Means, Independent Samples t-tests. And what the project's asking you to do is to compare men and women on M total. So the null hypothesis of this t-test is going to be that the mean of men on M total and the mean of women on M total is equal to 0. Or in other words, the null is that there's no difference between men and women on their average M total scores. So let's see. So I already have mine in here because I just did it, but you just put M total here, and then you have to make sure you define your groups for gender. So you just, well, here we go. I can show you. It's gender, and then define group 0, 1. Click OK. Let me just make sure my bootstrapping is off. Yeah, it's off. You don't have to do that. I was just making sure bootstrap was off for this. And I have to put M total back in. I don't know what happened. And then you can click OK. All right, so it nicely gives you your group mean. So I forgot, I think this is probably males. The mean was 3.38, female mean was 2.82. And then here are the results of our t-test, and we want to look at Levene's in particular. So let's first look at this. Remember that the null hypothesis of Levene's test is that the groups have equal variances. So we kind of want Levene's to be non-significant so we can use pooled variance. So, in this case, it's not significant. So I would say that we can use equal variance as assumed, like the pooled variance, which is in the equal variance as assumed line. So we would interpret this row of results, and we get a t of 5.15, which is associated with a p-value that's really low. So we would say p is less than 0.001 in this case. And this would be something that might come in handy for the final. I could see Bill doing something like giving you an output and erasing. I don't know if we've gotten to this yet, but just to show you, it'll be good to know. The way you calculate t given this output would be like, for me, I would calculate my mean difference score, so 0.55 divided by the standard error of the difference score, 0.10764, and that should give you your t, which for me it did. I didn't put all my decimals in, but it came pretty close to that number. And it should for you too if you want to just try it out. You don't have to do it for the project, but it's good to know. And so because this is a significant p-value, it's less than 0.05, what that means is that there is a significant difference between men and women on M total. Let's see if there's anything else. Yep, so just basically, if you guys do get a p-value that is less than 0.05 for Levene's, that means that you can't assume that there's equal variances between men and women, and you would have to interpret the line that says equal variances not assumed. All right, that's pretty much it for that.